Welcome to the ninth and final part of our assessment series. This time we are looking at non-parametric item response theory. So we're going to look at the purpose for this version, how to implement it, and then we will wrap up this series of lessons before discussing what the next series of lessons will be. So first, the purpose. Not all items have right or wrong answers. You can have opinion polls, customer service surveys, and so forth. And you still want to analyze those responses and look for correlations and patterns. But our existing item response theory that we've covered so far depends on having one answer that's correct and others that are incorrect, or at least having partial values available. So how do we implement a non-parametric version of item response theory? Ideally, you can use statistical correlations to compare responses to two different items. This means you need to have a logical numerical scale. Sometimes there's an instinct to assign numerical values to things just to make a numerical scale. For example, if you're trying to compare sales of ice cream flavors, you might say, okay, chocolate's 1, vanilla's 2, and so forth. That doesn't fit the requirements of correlations because those values are arbitrary. There is no reason to say chocolate has lower value than vanilla, which has lower value than strawberry, or so forth. Those numerical assignments become arbitrary. There has to be some sort of progression for correlations to work effectively. So if you really want the full mechanism behind correlations, you want to do an introductory statistics course. The version in a nutshell comes down to the idea that there's a correl function available in almost all spreadsheet packages that can calculate this value. Now, the range of values you get from a correlation, the lowest possible value is a -1. That means the change or changes in the first question or responses to the first question perfectly predict an opposite change in the second. So, the highest possible value on item 1 means that the person is also going to respond with the lowest possible value on item 2 and vice versa. If you get a correlation of 0, that means there is no discernible relationship between them. So, answers to item 1 have no predictive power when it comes to the answers to item 2. The correlation of +1 means that you have a perfect predictive power for proportionate results in the second. So the maximum score in the first question always results in the maximum score in the second question. Minimum score in the first question always results in a minimum score in the second question. So you have that perfect predictive power. So these are the kind of patterns you are looking for, and the way that the questions are phrased and what you're looking at will determine which is the preferred response. Unfortunately, this ideal is not always an option. Sometimes each item has to be resolved as a bell curve, because sometimes you are looking at ice cream sales. You do have to compare chocolate, vanilla, strawberry, and so forth, but you cannot put them on a numerical scale. So you just have to look at, responses to the chocolate item, responses to the vanilla item, responses to the strawberry item, and just look at that as a bell curve, or as a distribution of responses, what the average response is. So you still have to have a numeric value to each response to apply item analysis. Doesn't mean you're assessing chocolate as number 1 and vanilla as number 2, but it means you're, say, asking customers, rate our chocolate on a scale of 1 to 10, rate our vanilla on a scale of 1 to 10, and then you're looking at those numbers. Are most people responding with an 8? Most people responding with a 7? So these are the ideas that you're going for. You might even correlate that with, asking them in general, what do you like in your ice cream? Do you prefer a smooth texture? Do you, prefer soft serve versus hard ice cream, and so forth? And say, what preferences or what aspects of ice cream are you looking for? How does that compare to our own flavors? So in conclusion, The primary goal of assessment should always be to aid student growth. So the analysis of the assessment items should be used to guide future instruction. This is especially true of the formative assessment done during instruction. So this is where the teacher asks students a question about what's being taught, and then adapts the lesson plan according to student responses. So as a math and physics teacher myself, I prefer to teach with whiteboards instead of slides, so that if students are seeming to struggle, I can keep producing more examples. With slides, they tend to be pre-packaged. With a whiteboard, if I've done 3 examples, they're still not getting it, I could do 4, I could do 5, and I can keep going until they do seem to be understanding. We can also use these techniques with the non-parametric versions to figure out consumer surveys and other surveys and the like. Now, coming up next, I'm going to be adapting the other summer school series that we did on Bureau 42. At this point, I'm inclined to start with the Theory of Relativity series, then move on to the Quantum Mechanics. So those are the 2 series that were already done. They were already or previously released as 9-part lessons, just as the assessment was, but I think I'm going to break them down into finer detail when I'm doing them for YouTube. Doing it in 9 lessons would mean some of those lessons would be an hour long. So rather than call them 1 through 9, I'm just going to chop them into bits of more digestible length. I'm also open to requests. So you can email me, F as in Frank, I as in Igloo, Z as in Zebra, I as in Igloo, K as in Kangaroo, O as in Orangutan at gmail.com. Sorry, that's only being dictated and spelled to help avoid spammers. Or you can post right on the YouTube lessons with what requests you have for topics to learn. If it's within my field of expertise, I'll be very happy to produce them. And thank you for listening, and I hope you join us for the other series down the road.